Hello, everyone. I'm going to be showing you some highlights and giving a little bit of background on our paper in the SAS proceedings on characterizing variability in bright metallic line A-type stars using data from the NASA TESS spacecraft. The delta Scuti and gamma Doradus variables that I will be focusing on today pulsate in many modes simultaneously, both radial and non-radial. The delta Scuti stars are around twice the mass of the sun. They have pulsation periods of about 2 hours. The gamma Doradus stars are about 1.5 times the mass of the sun, and they pulsate in periods of 1 to 3 days, actually in non-radial gravity modes. The picture on the right is a Hertzsprung-Russell diagram, and diagonally from upper left to lower right is the main sequence where stars are burning hydrogen into helium in their cores like our sun is. The sun is in the lower right with the black circle. The gamma Dor stars are a little bit further up and to the left, and the delta Scuti stars are further up still in the blue circle in the middle. So these are near neighbors to our sun in type of star. We proposed that in the TESS guest investigator program during the last few years to observe metallic line A-type stars. These stars are in the same location in the HR diagram as are the delta Scuti stars. However, these stars have abundance anomalies that are caused by radiative levitation and diffusive settling in the atmosphere of the star. This same diffusive settling is also expected to cause helium to settle out of the pulsation driving region in the envelope of the star and turn off the delta Scuti pulsations. TESS observed in 2-minute cadence photometry samples of stars for 27 days time series length per TESS sector. There are 13 sectors during a year of observation. So far we have data from 32 stars from an AM star list from Catanzaro et al. And 23 stars from a chemically peculiar non-magnetic star list from Ponzin et al. And our goal is to determine whether these stars are pulsating and why they're pulsating if we find that they are. This picture shows the amplitude spectrum that was produced from Fourier analysis of the light curve of the brightest star in our sample that was observed so far, HD 50635. And this star appears to be a hybrid delta Scuti gamma Dor candidate. It's magnitude 4.7, so it's a naked eye object. These frequencies that you see on the right of this picture between around 10 to 20 cycles per day are the delta Scuti pulsation modes, and the modes between 1 and 5 cycles per day that are lower amplitude are the gamma Doradus pulsations. In the SIMBAD database, we could learn a little bit more about what is known about this star. It's also known as E Geminorum or 38 Geminorum, and it's in a wide binary with a binary orbital period of around 2,000 days and maybe even longer. And according to the literature, it was a suspected delta Scuti star. So this test data may confirm that it is a delta Scuti, and maybe it's even a hybrid star. Another star we observed was HDD 21643, and this star has low amplitude pulsations, only 70 or 80 parts per million in the delta Scuti range, and the low frequencies are so low amplitude that I would not call this even a gamma Dor hybrid candidate. That could also be rotation or star spots or just the background noise level for these observations. So the problem with this star is that the TESS input catalog says that it has a high contamination ratio. There are several stars in the field of view nearby that could be contaminating the light curve from this star. So we looked, in addition to the 2-minute cadence light curve product, we looked at the TESS target pixel data. And up above and to the right here, you see with the green and yellow squares, the target pixels around the star, which is the bright set of pixels in the very center. And you see up and to the right, there were also some bright pixels nearby. And if you make a light curve just using those 4 bright pixels that are highlighted in white, the white squares, and then do a Fourier analysis of those pixels, that light curve, you see that the amplitude spectrum below that is showing the same kind of delta Scuti frequencies as we saw in the previous slide. So it's very likely that the delta Scuti frequencies are arising from this nearby star, which turns out to be an A-type star, about half a magnitude fainter than HD 211643, according to SIMBAT. And in the right, you can see the star field where it does have quite a few stars around it, including that bright star off into the lower right. This is another star we observed that requires some follow-up. This is HD 43682. And while it didn't show obvious pulsations, it does show an eclipse during the 27-day light curve. You see the eclipse is around day 15, just after the light curve resumed after a break in the data here. So you can see the bright star in the field of view next to that. There are some faint stars around it, and so the eclipse could be as a result of a nearby star, but just examining the pixels, the bright pixels around in the center of this region, that seems to be where the eclipse is, and the eclipse isn't showing up in anything surrounding this star. So it could be intrinsic to the star. More data is needed because we just saw the eclipse happen once. The duration of the eclipse is 4.8 hours. The last two slides will just summarize the results from the two samples of AM stars we've looked at so far. The first picture, or this picture here, shows the Catanzaro et al. Sample of 32 stars on the HR diagram, along with the theoretical delta Scuti instability strip and the gamma Doradus instability strip. And out of these 32 stars, we found two delta Scuti stars and two delta Scuti gamma Dor hybrid candidates that will require more work to confirm and some follow-up. And here is the result for the 23 stars from the Poundsen et al. Sample. Again, we found two delta Scuti stars with the deltas and two hybrid candidates. So more stars are being observed with time. We've looked up to TESS sector 34. Cycle 3, the third year of observations, will end with cycle 39, and then cycle 4 will start up. So we expect to possibly get more data on these stars in the future and on additional stars in the sample, the bigger sample that we proposed observations for. Thank you for your attention.